network connections, and you don't have to be at the computer for this to happen. You can be sleeping, and your machine still gets infected, and it spreads the infection further. And these spread very, very quickly. How come they spread so quickly? Well, it's not that hard to imagine. How many IP addresses do we have in IPv4 address space? Well, actually, it's fairly easy to calculate. Just multiply 255 by 255 by 255 by 255, so you get 42 billion IP addresses, which isn't a big number at all. In fact, you can easily, well, not easily, but you can scan them all. And this is actually exactly what Blaster and Sasser and Slammer did. They scanned every single public IP address in the world. So if you were online in 2003, your machine or your phone or whatever device you had online with a public IP address was scanned multiple times by both Blaster and Sasser and some of the other ones. So they would just blindly scan IP addresses. Whenever it would find, of course, most of the addresses they would scan would be in use or would be unreachable or something like that. So, of course, nothing happens. But it just keeps on scanning. And when it finds a live IP address, of course, some of those IP addresses belong to computers it can't infect. So, for example, Windows Worm finding an IP address belonging to a Mac, so it can't do anything. Or sometimes it finds a computer which is online, which is the right operating system, so it's a Windows box. But there's a firewall, so it can actually reach the RPC port or the LSASS port. So again, nothing happens. Or there's no firewall, but the machine has already been patched. That's a patch, right? So it can't reach it. But of course, because it will continue scanning endlessly, eventually it will find a computer which is online, which is the right kind of a computer, which has no firewall and which hasn't been patched. And it will be able to infect it right away, right then, right there. Which means this machine will now start scanning. In fact, they are now both scanning the net. So it gets faster and faster. It grows exponentially. And this is the explanation how they could reach the whole net and scan every single IP address in the world multiple times. So what would Blaster look like when you get infected? Well, it would look like this. You would get an error message from Windows that the RPC process has a remote procedure call. Service has terminated unexpectedly. Windows can't live without that service, so it reboots. All right? And your machine will shut down and reboot. And then a couple of minutes later, you see it again. And it will shut down and reboot. Very frustrating. You can't work. What do? Well, you ask someone, like, what's going on? What do I do? Ah, that's a worm. You have to get rid of the worm. All right, how do I get rid of the worm? Well, you have to patch the RPC vulnerability. All right, how do I patch it? Well, you go to Microsoft.com and you download the patch. Again, at the time, we had no Windows updates. You had to do it manually. So let's do this. Let's go to Microsoft.com. We'll find the right patch. Excellent. That's the patch we want to download. Let's click on the download button. Yes, we want to download it. Let's save it. Let's put it over there. And now we're downloading. Excellent. It's coming down at a great speed. And during the download, you would typically get the same prompt again, because you still weren't patched. And now you have two counters on your screen. One is the download counter, trying to download the patch. One is the shutdown timer, calculating seconds on how long you have to go before your machine reboots. And this game was being played by computers all over the world. And as you might guess, many of the cases ended with the end user losing the game. Machine rebooting just when you were at 90% download for the patch. Then you try to do it faster. Very, very frustrating. And this is the reason why Microsoft changed their attitude towards worms. This is why they released Windows XP Service Pack 2, which had firewall enabled by default. This is why they changed their this security model altogether. They stopped developing new code for 2 months, had all the developers go back to look at the old code. That's why they started implementing Windows updates. So they really had no other option. They had to do something, and they did. And some of these outbreaks at the time were pretty massive. This is packet loss statistics on the day of the slammer in the whole net. On a typical day in the net, you have packet loss somewhere in the 2 to 3% rate. Suddenly, when Slammer started spreading, global packet loss jumped to 20%, which is pretty neat. In fact, Slammer managed to reach many critical infrastructure places as well, including infecting nuclear power plants, infecting train systems, plane systems, 911 services, ATMs. Pretty spectacular, especially for a worm which even didn't try to do anything like this. It was just trying to spread. But it nicely shows what kind of things we have online, or had online at the time. And critical infrastructure is something to worry about. It was already something to worry about 7 years ago, and it's still something to worry about today. A couple of screenshots I took at the time. This is Air Canada announcing that Blaster shut down. This is August 2003. Blaster shut down their flights. Here's a photo taken from the Air Canada checking desk. Can anybody spot what's the problem? Yes, it's the blue screen on the right side. This is a screenshot from CSX, which is the largest railroad operator in northeastern USA. And they have a press release out saying that they had an internal infection, which resulted in slowdown of major applications, including dispatching and signaling systems. As a result, all passenger and freight train traffic was halted immediately, including the morning commuter train service in the metropolitan Washington, D.C. area. Think about it. All the trains in the capital of the United States of America were stopped because of a computer worm. Isn't that incredible? But this actually happened 7 years ago. This happened. And there were many other places which were hit by Blaster, Slammer, and Sasser. For example, we were fighting a large outbreak in these. These are forest tractors, which, yes, run Windows. We had these shut down in the middle of forests. They wouldn't boot. I mean, they wouldn't start. So they actually we were working in a case where they were basically taking nerds in other tractors in the middle of the forest to figure this out and clean up the machines so they could actually continue forestry operations because they were infected by blasters. And then this is a screenshot from a Swedish magazine at the time saying that there were 5,000 computers infected in 2 hospitals in Sweden, which is bad, but that's not the worst. The worst is that not only computers got infected, these become infected as well because their X-ray systems were running Windows and they got infected and they were rebooting. So there were actual cases of patients being transported in ambulance cars to other hospitals to be cared for because the X-ray systems were infected by a virus in a hospital. But then we have something big, because the same year, 2003, we found Fissure. Fissure isn't very famous, but it probably should be, because Fissure was the first virus that we could conclusively prove that this virus was written to make money. And that's only 7 years ago. And of course today, all the viruses, all the malware is written to make money. All of today's attacks are done by organized criminal gangs who want to make money with their attacks. But the first case actually wasn't that long ago, only 7 years ago. Fissure made money by sending spam. So basically took over the computers and used them as an SMTP proxy and sent lots of Viagra spam through the infected computers. Very basic stuff. Only 7 years ago. That's when it started. So basically that also meant that the origins of where viruses are coming from switched. Before 2003, viruses were coming mostly from developed Western nations. Western Europe, USA, Australia, Japan, and they were written by guys who just wanted to write them for fun. After 2003, today, most of the viruses are coming from Russia, China, and South America. Especially Brazil is a hotbed of activity for banking fraud. And of course, Russia, I don't just mean current Russia, I mean pretty much all of the ex-Soviet Union. So mainland Russia, Belarus, Ukraine, Kazakhstan. In Europe, Romania probably would be the biggest hotbed of activity right now. And the virus writers changed from guys who looked like these, including here in the upper right corner, Checking How, who wrote the famous CIH, aka Chernobyl virus, which would actually, on the Chernobyl anniversary, overwrite your hard drive and overwrite your flash bytes, meaning that your whole machine would actually be inoperable. So these guys were the old enemy, and after 2003, the enemy looks pretty much like these. Professionals, organized gangs, the Ruskranians, that's Russian Ukrainians, and so on. So quite different. Today, the enemy makes millions with their attacks, which means they can afford to invest in their attacks. Moving on, we had Sovic, which was the biggest email outbreak so far in 2003, Wittyworm, which was actually infecting computers, Windows computers, through a vulnerability in a firewall. So there was a remote exploit in one particular firewall product, and it actually would get infected because you had a firewall. MyDoom, Bagel, Netsky, the first bots start appearing, and then we found Kabir. And Kabir is different because pretty much everything we've seen so far is DOS or Windows viruses. Kabir is a Symbian virus. The very first virus infecting mobile phones. This was 2004, so 6 years ago. And Kabir would actually infect your system through Bluetooth message. And one thing we noticed very clearly when Kabir came around is that when people were actually getting infected by Bluetooth-based viruses, Kabir, Warrior, or any of the other early mobile phone viruses, there was a very clear tendency to blame the user. Like, why on earth did you accept the Bluetooth message? Why didn't you just, deny? You don't have to accept Bluetooth messages. Why did you have Bluetooth on your phone to begin with? And this actually was unfair. It wasn't a user problem. And I can show this to you by this video. What we have here is a video we've shot in one of our RF labs. We have these shielded rooms where we can safely replicate mobile phone viruses so they don't escape. And here we have a Symbian phone which is receiving a Bluetooth transmission from an infected phone. You can't see, well, the other phone over there is infected. It's beaming the Kabir virus to this phone right now. So you can imagine that this is your phone, right? It's in your pocket and you're in a bar having a beer. Then someone else walks in the room with an infected phone and gets within your Bluetooth range, and the virus starts beaming itself to your phone. The way it shows up on your phone is this. Your phone says, receive messages via Bluetooth from, and the name of the sending phone. But you wouldn't notice that because your phone wouldn't ring, it wouldn't vibrate, it would just ask the question. So your phone would be in your pocket, you would be drinking your beer. Then 10 minutes later, you remember you were supposed to call your wife, right? So you pick up the phone from your pocket and try to make a phone call, only to realize you can't because there's this message on your screen and you can't ignore the message. You have to answer the message. So what do you answer? Yes or no? Well, of course you can answer no. No, I don't want a Bluetooth message. But watch when we click no button. The virus sends itself again. It sends itself again. It sends itself again. It sends itself again. So okay, let's ignore the message. Let's just make the phone call. Let's just call the wife. But the numbers don't work. No, you try doing anything, it won't work. Let's go to the menu and disable Bluetooth, but the menu button doesn't work. So you can't ignore the message. That's the problem. When we spoke to people and asked, why did you say yes? Why did you accept the Bluetooth message? They would always answer back that no, didn't work. I had to make a phone call. What else could I do? So what else could you do? What could you do in a situation like this? Well, you could walk away. Just walk out from the bar. Walk away from the Bluetooth range and the message disappears. Then you can make the call, then you can disable Bluetooth, you can do whatever you want. But this isn't obvious to the end user. Like, I got this weird message on my screen, so I'm going outside. Like, it doesn't make any sense, right? So no wonder. It wasn't actually a user problem, it was a user interface problem. Why viruses like these were a problem around 6 years ago. And of course, this was changed. Today, for example, phones like these would know. You click no and it will remember it. It caches it for half an hour, so you actually don't have the same problem anymore, and as a result, we don't have Bluetooth viruses in it. They've gone away. Then we have different bots coming around. First, rootkits appeared, including the infamous Sony rootkit, which we found in 2005. Sony still doesn't like us for some reason. We found the rootkit from these music CDs shipped by Sony BMG, including music CDs from Switchfoot, from Van Sant Brothers, and from Celine Dion. And I have friends who believe that if you listen to Celine Dion, you earn to be infected. So basically they had a copy protection system on these CDs. When you would use your Windows computer to listen to these music CDs, it would install a driver which would actually rootkit your system. And did that to hide the DRM system, but it actually turned out that it would hide pretty much anything at all, and we started to find viruses which were using Sonic rootkit to hide themselves. And there was a very nice quote given by one of the executives from Sony. Let me play it to you.
Most people, I think, don't even know what a rootkit is, so why should they care about it?
Thomas Hesse is president of Sony BMG's global digital business.
I think was such an excellent quote. We actually made T-shirts out of it, so maybe that's one of the reasons why Sony doesn't like it. Then we started finding more larger outbreaks, including Stormburn, which I have a short video here as well. We actually shot this in our lab from one of our systems which tracks infections around the world. So all the dots you see on the map are just normal viruses. But we get closer and closer to midnight, so it's now 6 p.m. You can see the clock ticking away there in the corner. And around midnight, the outbreak starts, and you'll be able to tell pretty clearly. So it's 10 o'clock, random infections. This is not yet storm, and storm starts here. So that's what an outbreak looks like. Like millions and millions and millions of infected machines around the world.